Supplemental math videos from Circle Christian School. Asymptotes, the place where the function gets very, very close to, but never crosses. These are the basic guidelines for graphing a rational function. And a rational function, you'll remember, has the numerator, a function in the numerator, and a function in the denominator. If at all possible, make sure that you can simplify the function. And then any of the restrictions should be noted. That is, you need to note what x could not be, what the domain is. Try to find and plot the y-intercept, if there is any, by using f of 0. That's a 0. It's kind of just dependent on the font. And 3, find the vertical asymptotes. 4, check the degrees of the leading variables to determine the horizontal asymptote. Remember that if the degree is higher in the numerator than the denominator, there is not a vertical asymptote, but if it happens to be the same, then it is the leading coefficient over the leading coefficient. And next, just pick some reasonable x inputs to put back into the original equation to work out your curves. Let's find the slant asymptote for this particular function here. Okay, so the first thing that we're going to have to do is discover what the vertical asymptote is, and that's pretty easy because of the x right here. So we know the vertical asymptote is going to be a positive 2. Doesn't have a horizontal, so we got to go find the slant asymptote, and we're going to use that synthetic division to discover the equation of the line. All right, remember it is the coefficient for each one of the terms inside the equation here. Just make sure you go down by degree order. The negative 2 here says that the root is a positive 2. And we're just going to work our way through it, bring the first one down. Everything on the outside gets multiplied to the next guy, so we get a positive 4 and a negative 1. And then, of course, to the next guy here, which we almost don't have to do because it's a remainder, but it doesn't hurt to do it. So that's going to be a negative 2. So we end up with a remainder of a positive 3. So this is going to be 2x minus the 1. You can look at it as y equals the 2x minus the 1. So the slant asymptote is going to be 2x minus 1. All right, so now we're going to draw our asymptotes. So the first one we have is, of course, the vertical one here at 2. And the slant one is going to start at negative 1 here and go up 2 over 1, up 2 over 1, just graphing a regular line. And then you can just do a test, an easy test. Pick a nice easy number or throw it back inside. See what kind of equation you get out of it. And, let's see. Let's take the easiest one. Yeah, let's take the easiest one here at origin, 0, 0. So we have 2, 0 squared minus the 5 times the 0 plus the 5 all over 0 minus the 2. So this is, of course, going to be 0. This is going to be 0. So this is just going to be 5 over the negative 2. So 0 at 5 negative 2, or negative, 2.5. So 0 and 2.5, negative 2.5. So down here, negative 2.5. So that means one of them is going to be inside here. and the other one's going to be inside here. And there's our little slant asymptote. So sometimes it's kind of good to look at things in kind of a slant view, especially when you're working with not asymptotes, but asymptotes. Have an awesome day, guys.